Hello wonderful person, this is Anton and welcome to yet another TRAPPIST-1 video, but this time is going to be a hypothetical video where we're going to play around with the system and possibly discover how habitable it really is. Anyway, let's start this video and welcome to What the Math. Now, so what I wanted to do in this video is basically erase all of the TRAPPIST planets, which are kind of Earth-like, but not really Earth-like. And of course, replace them with the most Earth-like planet we know. Everything here will become Earth. And we're going to see how our new 7 Earths will perform in this TRAPPIST-1 system. We're also going to talk about sciences and various effects here that will make life in the system very difficult. But let's just start by placing them first. TRAPPIST-1b, your orbit is about 151 days, and I believe the eccentricity here should be about 8%, and also the inclination should be about 89%, but we're going to ignore inclination because they won't really change anything. So let's remove TRAPPIST-1b, and let's now place our beautiful planet Earth as the first contender in this new system. And let's maybe name them as well, just so we'll remember which planet is what. So this will be Earth B. Then we're going to place Earth C right here, where TRAPPIST-1c is, with the orbital period of 242 days. So let me just skip this part and I'll just place all of these new Earths manually by changing their orbital parameters and of course their names as well. Next is TRAPPIST-1d, E, F, G, H, and here we go. So A, B, C, D, E, F, G, H, all of them in the exactly same position as the original planets of TRAPPIST system. And anyway, so here we go. We have 7 Earths in the orbit. I'm going to actually remove the orbits for now. C and B are a little bit too close to TRAPPIST, so it's very likely that there's going to be no liquid water left, but we'll see in a few minutes. D, E, F, and G are very likely going to have some liquid water because they're sort of within the green habitable zone. And then H possibly will have frozen water because it's too far away from the star. So let's actually run the simulation for, I don't know, like a few years or something, and just look at the temperature go down. That's pretty crazy. And let's see what actually happens to our beautiful 7 Earths that orbit the TRAPPIST system now. So I'm going to just kind of make this simulation run itself for a while. And we also might be able to see some of the interaction between the planets because they're relatively close to each other, which means that they might start pulling on each other and create all kinds of different synchronicities. In reality, TRAPPIST-1 system has a lot of tidal locks, but also has a lot of resonances between these planets. So they actually are always in some kind of a resonance with each other. I obviously place these very randomly, so there's no resonance whatsoever here. But we might discover some later on. Anyway, so looks like the temperature on Earth H is still dropping, but it's already quite a visible ice ball. It's basically too cold here for water, and it's going to be a really cold ball of ice. Also, it's much farther away than the other planets, so one orbit here is about 20 days, meaning that it's very likely that it also spins much slower. So if I were to tidally lock this particular object by pressing this button right here, you would see that one day here would be 20 days long. This also implies that one side would always be facing the sun, and this side right here would eventually get really hot, and there might be some liquid water on the outskirts where it's not as hot, and most of the planet would be covered completely in ice. So that's Earth H. Definitely not going to be a very habitable place. Earth G is sort of within the habitable zone, and the temperature here is still very cold. And that's actually a lot colder than I thought it would be. Now, this is because the greenhouse effect here didn't really do much. The actual greenhouse effect due to the atmosphere on our planet is usually about 32 to 33 degrees Celsius, or just degrees in general. And here our temperature, our even if we were to increase the greenhouse effect, it's still kind of too low, and it's still actually dropping. So this might even be lower than that. So Earth G is also not a very nice place, unless of course it has more atmosphere. If it has more atmosphere and more greenhouse effect, in that case, it might actually have liquid water, but for now, it is a frozen world. And because it's also tidally locked, which I should do right now, it's going to have one side that's a little bit too toasty. Let's go to Earth F and look at that. This one is also very cold. What is going on here? Now this is very interesting. So even though all of these planets are actually in the habitable zone, these Earths in Universe Sandbox seem to be a little bit too chilly. They don't seem to get enough energy from TRAPPIST-1. Now I'm starting to wonder if maybe it's because of other factors, like albedo effect maybe. Although that albedo of 0.32 implies that the majority of light on our planet is actually absorbed. And I'm not entirely sure what's happening here, but I just realized that there seems to be occasional eclipse going on around this particular planet. And let's see if this is actually what's happening here, because I think I just witnessed a shadow passing by, and I'm guessing it's because of another planet passing in front of us. And so we might actually witness one of those occultations or one of those eclipses in a few seconds right now, actually. Let's see if this is what's happening. So there is Earth B passing in front of the TRAPPIST right now, and nothing. Oh, there we go. Look at that. That was a huge shadow. That was definitely a huge shadow from Earth B. Wow, that's awesome. So on this particular planet, you would be experiencing 1, 2, 3, 4, at least 4 different eclipses once in a while when the other planets come in front of the star. On Earth H, however, that's 6 different eclipses. That's a lot of eclipses. Anyway, let's move on to the next Earth. In this case, it's the one down in the alphabet, Earth E. And once again, a little bit too cold, but maybe not as cold as the other objects. So here the temperature is minus 17 degrees Celsius. Lots of eclipses. Look at that. I should probably also make this tidally locked just to make it more realistic. And now we tidally locked our planet to basically make North America ridiculously hot. So North America is going to be always facing the sun now. But as you can see, the temperature here is cold, and it's still falling. It's falling even lower. So that's not a good sign either. That means that so far none of these Earths, plural of Earth, have actually been warm enough or became warm enough to be habitable. Except for Earth D. Look at that. Beautiful blue world. Is the temperature stable? Yeah, it's a stable 18.4 degrees. That is amazing. Okay, so let's once again tidally lock this. And now I've actually tidally locked Australia, Southeast Asia, and Asia in general. And we seem to have a relatively nice, relatively cool looking world here. 18.3 degrees Celsius. It's just a little bit warmer than Earth on average. As you can see, the caps actually, the ice caps have kind of disappeared, which is not really good. And the temperature is still kind of climbing. But basically, for Earth to have a perfect climate, Earth-like climate, it would have to be located somewhere between D and E. Maybe just a little bit after D. Now, I'm guessing Earth C is going to be toasty. And the answer is yes. 68.5 degrees. Look at that. Look at that. Everything here is completely brown. Essentially, all of the vegetation, all of the life has been eliminated from the surface. There's still a little bit of water left, but it's probably all boiling, or at least very, very hot, very steamy. And so this Earth is not a very habitable Earth, although the star from here looks pretty impressive. And the last one is, of course, Earth B, the closest to the star. And here the temperature is over 100 degrees Celsius, over boiling temperature of water. So most of this water is probably boiling hot. It's just ridiculously hot. And it's probably only in liquid form because of the pressure, if there's any water left at all. And now you can actually see some of the continents here, or the continental shelves, that is, because a lot of the water has evaporated from those continents, making them a lot larger. So, which is, of course, very, very, very interesting. Anyway, so, well, looks like only one of these Earths was habitable. And that, of course, is Earth number 3. Specifically, we're here talking about Earth D. So this is the only planet that so far has actually relatively nice conditions for us to live and actually has green vegetation on the surface, which is, of course, great. Now, the only problem here is that it still is not going to be a world we'll be able to survive on. And there's maybe two main reasons for that. One of those reasons is there might be not any magnetosphere here. Now, we don't really know exactly if any of these planets would have a magnetosphere. Our planet clearly does, and it protects us from pretty much everything. But if there is no magnetosphere here, it's very likely that all of the atmosphere and all of the liquid water would actually be stripped away and disappear completely, which I'm going to do right now by removing all the water. And there you go. This is what this would look like. And there would also be absolutely no atmosphere and also no clouds. There you go. Empty world. Now, the other thing is, even if there is a magnetosphere, it has to be really, really strong. And it has to be strong because we're so close to TRAPPIST. We're very, very close to that star. And this star, just like other red dwarfs, is, as you can see, a little bit active. It has a lot of flares going on. It has a lot of emissions, which makes it a very dangerous star to live around. Those emissions can be very powerful, a lot more powerful than the emissions from our sun, which is actually a very mild star. And every one of those emissions would very likely destroy any possibility for life. It would just kind of strip the surface of the planet from everything. So the only way that Earth D could actually have some kind of a life on it is if this life formed maybe in the shadow right here, where it's kind of warm, not too cold, and basically in this region right here, when we're kind of covered from the sun for the most part, but there's still a bit of a warmth going on, or possibly even the liquid water. This is where we might have this kind of a twilight area life, twilight life, as I guess you could call it. And other than that, these planets, for the most part, are going to be very, very difficult to survive on. And as this kind of gives you an idea, especially if I look at the chart here, just to show you what each of these planets looks like, and also in comparison to TRAPPIST-1 itself. So there is the star, and there are the planets as well. So most of them are kind of too inhospitable, with the exception of the third planet from the sun, just like in our own solar system. These ones are a little bit too cold. And so anyway, so that's all I wanted to say in this video, and hopefully you learned something from it. And if you did, don't forget to subscribe, and also come back here tomorrow to learn something else completely different about some other star, planet, or possibly some other scientific fact. I'll see you guys in tomorrow's video. Space out, subscribe if you still haven't, share this video with someone who enjoys watching these videos, and as always, bye-bye.